Good evening. Bonsoir. Thank you very much for the extensive introduction. I didn't know all that about myself. I don't know where they found it, maybe on the internet. Thank you, everyone, for coming out tonight. We're going to talk about maps. I love maps, and you'll probably find this out throughout the night. Tonight, we're going to talk a little bit about the history of maps, where they came from, where they've been. We're going to get into GIS, as you heard, it's Geographic Information Systems, and how that works. After about 10 or 15 minutes, we'll take a short break, allow you to get another drink, use the restroom, talk amongst yourselves. And then we'll get back into it, and we'll talk about the applications of maps and GIS in science. With this, I'll include some of the work I've been doing, as well as some of the great work done by other cartographers I know around the world. After that, I'll talk a little bit about something called OpenStreetMap. And rumor has it, it's karaoke night here at Big Willie's, so if you're into that, stick around. So when I give a talk, I don't enjoy talking the entire time. I also enjoy giving away prizes. So tonight, we're going to play a little game. I'm going to ask you a question, and I'm going to hope that you answer. If you answer correctly, I went over to the ShopRite, and I found these cute little polar bears made of chocolate. So, let's see, how about the first question, huh? Okay, I want you to close your eyes for a second. Think about your day. Think about waking up, getting out of your bed, going into your kitchen, having a cup of coffee. You leave your house, maybe you go to work. Maybe you go to a shop. Maybe you're in the car, maybe you're walking. What are you seeing? I mean, is there a red house? Is there a tree? Is there an intersection where there's a particular dog sitting? What does it look like? Later in the day, you start to head to Tamarin and come into Big Willie's. Think about that road. Did you take a road? Did you walk? Did you ride your bike? Did you drive? How did you get here? Now, open your eyes. Who would like to share with me how they got here? Who can give me directions from their house, and how would you do it? Come on. Would you like to answer? They're polar bear chocolates. Thank you. What's your name? Peter. How did you get here today?
So just from home to this event, right? So we met with the guys in La Golette. We entered the car, and we just hit the main road. Came all the way straight here.
Where's La Golette?
It's just the next village after Black River.
Do you know the direction?
It's to the south. It's just along the coast.
How do you know you're going south?
From here,
Yeah.
I know the map, so.
Does the ocean help?
Yeah, because it's the coast, and if you know how Mauritius looks like, then it's
If I
easy.
don't know Mauritius, how do we get to La Golette?
Just follow the road, the main road. Don't leave the road, just go with the road.
Don't get distracted.
No.
Do you know the name of the road?
No, it's the road. I don't know.
If I had you draw it, could you draw it?
Yeah, it's the only way. There's no other way. Right?
Are you right? Okay, thank you.
Yeah, welcome.
Thank you, Peter. He said the magic word, though. He said map. So he has a mental map. He doesn't need a paper map. He hasn't used GPS. He just knows the way. He knows it's south. Maybe he's lived here a while. Maybe he's got a good sense of direction. But this isn't always the case. Someone calls you. They say, I'm at a roundabout. I've got 5 different directions I can go. Which one? And you think back and you think, which way do I actually turn? You know, because sometimes it becomes automatic. For the next one, you might need some assistance. Peter gets a chocolate, by the way. You got one. Can you give it to him? Thanks. Okay. If I were to drive to Port Louis from to Grigri right now, how long do you think it would take? And can you tell me the distance? Anybody off the top of their head? Now, I urge you to use something you might have in your pocket to do this exercise. Is there traffic? How long will it take? What's the best route? Does anybody have an idea what I'm urging you to use? Smartphones. All right, the first person to call out the correct answer will get a little polar bear. GPS, but what's the answer to the question? How long will it take me right now, in this moment, to travel that distance? Use your phones, use your phones. You're guessing. I like your guess, though. I need precision. 1 hour, 1 minute. And how many kilometers? 47. What route will I take? The coastal road. The only road. Okay.
All right, we have a second mic now, and
Great.
I can free you.
Thank you. I'm untethered. All right, what is your name? What's your name? Sean. Yes, thank you, Sean. You had a good guess, didn't you? I think we can arrange that. I think I have an extra. Will you do the slide, please? See, he's still looking it up. His phone's not so smart. All right, this one's a little more difficult. We're going to go back to where I came from. With those same devices, can somebody tell me what the distance from Philadelphia to Washington, D.C. might be? The distance never changes, but the time to get there changes quite a bit. Candy. No, not yet. Do, 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 do. How many people have smartphones in the audience tonight? Many. 2 hours and 30 minutes. 139 miles. That's correct. I know that very well. I go back and forth all the time. What road is that? I-95. And is there any traffic?
I don't know. Let me zoom in.
To walk. You are correct. How did you know this? Yeah. I'm not going to walk. But you could find out if we took some more time.
Oh, yeah, there it is. Yeah, it looks green.
Green. Green means go. Great. Thank you, Mike. Here's your chocolate.
Oh, thank you.
And your name? Can you catch? I can't throw. Thank you. Okay, so I'm trying to make a point here if you haven't gotten it. It's pretty easy to figure that out. If you have a device, they're all over the place now. You can ask your neighbor if you don't, and you could probably figure it out. But it hasn't always been so easy. I thought these were kind of funny. I combed the internet for cartoons about maps, and this is what you get. In preparing for this talk, I also learned that the #1 cause of argument while couples are on vacation is finding the way to go, is navigation. Even if you have a smartphone or a paper map, it doesn't matter. It's the #1 cause of argument on vacation. Does anybody have that experience? I know I have. So yeah, it hasn't really been this easy. You can't just pick up a device and it tells you what to do. So now we're going to go back in time. This is a picture of one of the oldest maps in the world. They found it on a mammoth tusk in the Ukraine. To me, this is brilliant. It's portable. Mammoth tusks have to be pretty big, but it's still easy to move around. Depicts a river and some houses and some ways. About 5,000 years later, they found this one. It's painted on a wall, and it's more of a plan form. Walls are pretty difficult to move, so you'd have to memorize this before leaving the wall. Turkey, modern-day Turkey. This is one of the earliest known maps of the world, done by the Babylonians, 2300 BC. And in this way, they depicted the world as two concentric circles. And I don't know if this is narcissistic or not, but their town of Babylon, Babylon was right in the middle. They were the center of the universe. Don't ask me to read those words. I don't know what it says. Fast forward another couple hundred years, and they started putting maps on papyrus. You can see in the left-hand corner. On the right, that's Homer's depiction of the world. You can see it's starting to get a little more detailed, and Egypt, Libya, Ethiopia, there's seas on there. We're gaining more ground as people begin to travel and gain perspective. A man named Herodotus drew this map of his world. You can see current-day Saudi Arabia starting to form, and Sun of the Seas, northern Africa, part of Europe, and they're even getting so far as what they thought was India. Thanks. Another couple hundred years. We're going quickly through time. I apologize, but there's a lot to cover today. And you can see again, it's getting larger, and they're starting to put methods of measurement so that people can understand scale and distance. In 150 AD, this map was found with the first references to latitude and longitude. Is everyone familiar with latitude and longitude? X marks the spot. And this is what, 150 AD. We fast forward about 1,400 years, and this is the first undisputed map of the Americas. There were many done before this, but no one fights over this one. So that's why it wins. It's 1,500, and most likely done by someone in Portugal or Spain. I didn't look it up. Has anyone seen this map before? Do you recognize where it might be in Mauritius? Southeast? I don't know the answer to this question. That's why I'm asking Mauritians. I was going to guess it looked like Mayabu or Blue Bay. Was I right? Thank you. So in 1884, apologies, this is when people started using maps. You can see in the past couple thousand years mainly showing place, describing where you are. This is a map of London, a part of London, drawn by a man named Dr. John Snow. Anybody recognize the name Jon Snow? Game of Thrones fans out there? I wonder if he knows this. So there was a cholera outbreak in the city, and no one quite knew how to stop it. And Dr. John Snow had a hypothesis that the disease was spread by water. So what he did was he started mapping the cases of cholera, going to people's houses, seeing who was sick, and putting them on this map. And then he started mapping the wells in the city. And they were able to see that the number of people, the density of cholera cases was highest next to one of the wells. So he brought this to the attention of the municipality. They shut the well, and the cholera outbreak stopped. Well, diminished. So in 1854, this starts showing the use of maps for showing place, but also showing data. And this is a very important turn in map making. I just thought this was a beautiful map of Mauritius. I showed this at a school here, and many students were familiar with it, so I think it gets around. Mauritian cartographer, made it in 1880. He started his craft in 1870, I believe, and within 10 years he had the entire island mapped, which is pretty impressive. Rivers. Where are you going? We're in Mauritius, yeah. That's good. Perfect. All right, 100 years later, something called GIS was invented. GIS stands for Geographic Information Systems, and it was invented in Canada by a man called Dr. Roger Tomlinson, who is known as the father of GIS. The Canada Geographic Land Inventory wanted to start mapping forests and soil and all these things that are pretty complicated to draw. And he came up with this program where they could do it much easier than using photozincometry to draw the different layers and layer them on top of each other and all this photography work. So I was looking for a photograph of the actual program, and I imagine it's pretty big, but I couldn't find one. So what is it? I like to tell my students, I know you're not my students, but get the visual anyway, it's kind of like a giant sandwich. You know, you start with the bread. You know, you have your base layer, and you could think of that as like the earth. And think about all the features around you. We have sidewalks in some places, grass, topography. So you start adding those to your map. Water features, you want to add the ocean and the rivers. Then you have buildings, another layer. On top of that, maybe you have some satellite imagery of the area that will help visualize where you are. And in the case of John Snow, you start adding health data or epidemiology and start analyzing, you know, where the highest rates of mosquito bites are happening or things like that. So you have all these layers, right? And you have this giant pile of data. What GIS does effectively is it brings it all together and allows you to manage it and look at it and analyze it and pull it apart and put it back together. Here's another picture of it, so you can start kind of visualizing what it looks like. This one shows the elevation at the bottom. With GIS, you can show 3D. You can start showing that topography and 3D imagery. You put an aerial photograph on top of that, and then you have the texture of the mountain. You can analyze it and see where the highest points, the lowest points might be. Any pipelines, the roads. So that goes into the computer. Everybody see that joke? It's in the computer. Grids it all up, puts it into a stack, and voila, you have a GIS. This is a very pared down description, but we could be here all night. Okay. You're going back, you're going forward. Yeah, going up. Quantum. Okay, this is a GIS program that I use. It's called Quantum GIS. You could download it on the internet. It's open source. It was created 14 years ago, and they constantly are working on it. It's a software program like any other, Microsoft PowerPoint, Word, CAD. It's a good comparison. You just have to learn how to use it, and then you can make a map. It's pretty simple. So I choose Quantum GIS over other ones. There's a few other out there, including ArcGIS, because it's open source. Is anyone familiar with the concept of open source? Anybody? All right, you want to tell us what it is? I'm talking too much.
Essentially, closer, man. Okay. Hello? Okay. So essentially, open source is created by community members. It's usually free. So it's a bunch of people contribute and work together to develop software. And well, I'm a software engineer, so I know mostly the software part. So yeah, so basically, a lot of people contribute and give their time. Sorry. and they come up with these very complicated products, complicated software that more or less emulate the paid alternatives, but they're more open and they're more sometimes they're more advanced than the actual paid version.
Yeah, so they're alternatives to paying. For me, as a consultant and startup, I couldn't afford the alternative. So I wanted to work in open source, but I hadn't used the program. I had used all the time the ArcGIS, and then going out on my own, I couldn't afford the $15,000 price tag that came along with ArcGIS. So there's a motivator there. But now that I'm in the open source world, I wholeheartedly support it, even if I had the money to pay for the alternative. It's free. It gets updated much faster than the other one. And there's a great community around it. I mean, people spend their free Saturday nights building the software. You can't really beat that. If you have an issue, you can send it to someone and you can see their face and you can have a conversation with them. So yeah, I won't go on about open source, but it's going to come up later as well. Here's a screenshot. How does it work? It's a visualization of data. If you've used spreadsheets or tables or anything of the sort, you're visualizing data. You're looking at trends. So what GIS does is it takes that table, picture an Excel data sheet, grown, right? It has all those columns and rows and all the data. What it does is it brings it into a screen like this and it makes a picture out of it. This is a picture of Baltimore City, where I used to live. It's all of the roads and the outline of the city. You can also add, you can see the layers on the left side. Remember I talked about the sandwich? They're all on the left. And you can add and subtract. You can change the colors. And really, it's as simple as finding the data and bringing it into the program. If I were to open up one of these files, I would see an Excel-type spreadsheet. It would be a database. And it would have the names of the roads, maybe the speed limit, the distance, any major intersections, if it's paved, if it's a dirt road. All that data can be found in this database. So you take that paper map and then you add all of these layers and depth to what you can do. I can find, what roads might need to be paved. They can start marking potholes. They can start marking, okay, this is where we should build a beltway or something along those lines. So yeah, think about it as a way to visualize any kind of data. Here's an example of what I was saying. What would you rather look at? They're both showing oil consumption by country or region. And the map on the right I made in Google Earth. And you can go in there and play with it and turn it around and click on the different colors to see what countries using what number of barrels of oil per day. And on the left, to me, it's not quite as fun. They both work. Granted, but with maps, you can probably tell a little better of a more powerful story. So we're going to take a break so everyone can refresh their drinks. And next, we're going to talk about maps and how you can apply them to science. Nobody knows that. Thank you. Thank you. Welcome back. So just to recap, we've gone from left to right. From a world of carrying around a stone to carrying around a small device in our pockets. The one on the right is a picture of Facebook connections. Can Google this one and find it and play with it online. And today there's so many gadgets you can find with GPS, GIS, maps integrated into them. Drones, watches, smartphones. The guy in the middle on the top has a really accurate GPS on his back. So the two keys here are technology and data. What are you going to map if you don't have any data? So the question is, where do you find this data? Well, sometimes governments open their data. Here's an example of the state of Maryland in the US, who decided to put all of their data on the web for the public to consume. This is happening all over the world. The There's an initiative by the World Bank to get governments to open not only their geospatial data, meaning data with a place, but also their financial data and all kinds of administrative information, just putting it out there for the world to see. I think it's a great initiative. Here's another company, Natural Earth. They provide anything you can think about related to the earth, water, relief, hydrology, topography. You can find background imagery for any of your maps, all downloadable for free. You can see on the right-hand side, get the data, and it's pretty simple. Another way to get data is through satellites. Satellites are constantly orbiting the Earth. They collect imagery. They help you talk on your cell phone, the TV. They're looking for other planets. There are many satellites orbiting us right now. This one's for a prize. Can anyone guess how many satellites are currently in orbit? 570 from the stage. 10,000. Maybe a little lower than that. Somewhere in between 500 and 10,000. This does not include space debris. Artificial satellites. I really like it. 5,000. Oh, stop. No, this is supposed to be a good guess. I'll eat the chocolate. 2,771. 72 now. Something just went up, I think, in the last half an hour. So there's a lot of stuff floating out there and spinning around the Earth. You probably at night, if you're watching the stars, you've seen them. You think, is it a plane? No, it's not a bird. It's a satellite. It's probably a satellite. I hope it's a UFO, but it's usually a satellite. So if the satellite imagery is not very good, another option to find data and imagery is to get your own drone, which I decided to do because many of the places that I decide to map don't have very good resolution in their imagery. So you can use a drone. I've never seen one. There's a camera. This is the first DJI Phantom, so it's not very fancy. I'm a startup. I bought my own camera. On the right is a short video of a nonprofit called Digital Democracy, and they help small communities in Peru to map their lands so that they don't get taken over by oil companies and mining companies, and to show, in this case, it's a 3D model that they made after building their own drone out there and then flying it over their land. So they can say, this is what's here, and then they can start to protect it. This is a simulation. So yeah, this is Digital Democracy. I urge you to check out some of their work. They're doing great things. Another option that I enjoy, especially in small communities, is balloon mapping. I don't have my balloon with me today, but picture a giant red balloon in the sky, and you walk along. It has a camera on it, and it's constantly taking photographs. And you just walk where you want to film. This could sound messy, but some brilliant developer out there built something called MapKnitter. It's open source, free, that helps you to put that jigsaw puzzle together. So you have all your images from the balloon, and then you can bring them together. And on the right is an example of what this looks like. So if you don't have a drone, a balloon works. There's also people who use kites, but I find that the balloon is a little bit easier to walk around with. The other beautiful thing about the balloon is if you're walking around a neighborhood, people are curious, and they're going to say, what are you doing? Oh, well, we're making a map of your community, and starts a conversation, and you get more people involved. Sometimes you have to get to the nitty-gritty, though, and you have to just get out your GPS, take a piece of paper, and start walking. So here's This GPS has been all over the place. It's not very fancy. It takes the latitude and longitude, takes where I walk. Sometimes that's all you need. The top left picture is some students in Baltimore mapping a retail area in the city, making notes on what shops are there and status of the buildings, seeing if there's any damage. I was fortunate to work with MMCS to map some of the birds and sightings. So that's the bottom left corner. Sometimes work takes you to beautiful places. And on the right-hand side, I'm in the middle of the woods with my smartphone using an application that was built to rate the amount of invasive species in an area. So you don't always have to even have a GPS device. You can put an app on your phone and you can start mapping. So you've gone out, you've collected your data, you learned how to use GIS. What are you going to do with it? This is a GIF of the polar ice cap and how it's changed through the years. I found this on National Geographic. It's pretty powerful to see how much ice has been lost, actually. I just saw this right before I came. I added this to the presentation. So if you've ever checked the weather, here's another satellite, and it is helping you to know what to wear, whether to bring an umbrella. Pretty straightforward use of GIS, but important nonetheless. Again, here's Facebook connections. If you use Twitter, this is a feature I believe you can do as well, as you can map your tweets and you can see who you're connecting with and where they are and where you're tweeting from and build your own network. And sometimes you can do it live, which is pretty cool. For the environment, you can start looking at terrain analysis in 3D. I find this important, especially when you want to do coastal vulnerability, landslide prediction, anything that involves earthquakes, things falling down from the land. If you want to build on a slope, getting the aspect of the slope, you can do all that in GIS. You can see on the right, they show you kind of the different layers involved in this. This is a beautiful map I found done by a group called CartoDB, who also has some software on the web for building web maps. It's all of the rivers and their tributaries in the US. This is only the northeastern corner of the country, but what do you think the colors indicate? Anybody have a guess?
Land use. The red is vegetation. No? Oh, the black is definitely water. The lakes, the black are the lakes. Really? No, that's the Michigan Lake and the Huron Lake and the Superior Lake. Ah, the rivers, okay. No idea. I just thought the red was vegetation and the black were the lakes.
I think it's the partial pressure of oxygen and carbon dioxide.
Thank you for guessing. The colors indicate the flow direction of the river. There are 18 different colors in this map, and it can tell you which way the river is flowing. It's interactive as well, so if you go online, you can see the rivers flowing. This is pretty cool. Predictive modeling. This could be an important thing for a place like Mauritius, perhaps. Where is sea level rise going to happen? What parts of the island are vulnerable to flooding? Rivers from the coast. You can see in Florida where you shouldn't buy land on the left-hand side. And the prediction of the Brisbane River on the right in Australia. This one hits home. I used to live next to that river, and I think the part of town where I lived will be underwater, which is pretty wild. It can be used for agriculture. This map shows crop water usage and how much water the crops will need. Pretty basic. It's China. Sugarcane yields worldwide. There's a little green dot there. It's very dark. It's Mauritius. I think it's about 3,500 kilograms per hectare. Ebola cases. When I told my family I was going to Africa, I had to show them this map and show how far away South Africa was from Nigeria. The Ebola outbreak, which is pretty sad. This one shows water currents and wind. Those surfers out there, kite surfers, it's real time, and you can go onto this website, zoom as far in as you like, and you can see the currents, so you can see what's coming. This is mesmerizing to me. Now I'm going to talk quickly about some projects I've done over the years. If anybody has questions or I speak too quickly or you can't hear me, just wake me up. This is a neighborhood in Baltimore, and they wanted to map the population changes over 10 years. So the data was out there. We had the demographics from 2000, 2010, and you can map the change. The picture of me with the cell phone in the forest was this land. It's 400-acre park in Baltimore, and they wanted to map invasive vines. So I spent an entire summer hiking this park and mapping the intensity of vines. So all the dots you could see was where I had walked so far. Remote sensing is something else you can do in GIS. That's an entire field. I could speak for weeks about remote sensing. I won't do that to you tonight. Project on the left is one I did to look at the Three Gorges Dam in China. I wanted to see what was displaced and how much water there was in the dam in the reservoir after the dam was built. And I found that it displaced from outside sources 1.5 million people, and the lake is over 400 miles long. So with 2 different satellite images, you can do something called change detection and subtract them from each other, and voila, you have the area that changed. You can also use GIS in conservation. I like to say, how are you going to protect something if you don't know it's there? In this project, all I had was a Land Rover, a GPS, and my computer with QGIS on it. And we drove around the property. The project was for the Narrow Sand, if you've heard of the Bushmen. This is their land, and they didn't have a proper map. So we drove the land and mapped wells, campsites, potential future sites to build something, and they ended up putting it on the entry to the property, and I'm going back there next week to do the same thing, but to start counting the animals that they have on the reserve. So we'll be using the drone and the GPS and finding different water holes. Another conservation project is Lake Savaya, another change detection exercise. We're using mapping to see how much water the lake is losing. It's at historically low levels, and they're afraid that the lake in the next 5 years might completely disappear or become inundated with salt water. So the map over in the corner, I did that today. I took an image from 1986 and an image from 2015. I traced the outlines of the lake, and you can see the green is today and the background is 1986. Unfortunately, it doesn't show the depth, but you can see that it's changing. Maps are also integral to disaster management and response. I wasn't involved in this directly, but there's a group out there called Hot Awesome, humanitarian OpenStreetMap, and they began using the open source version of Google, basically, OpenStreetMap, to map places that have been affected by a disaster. It started in Haiti after the earthquake. They used imagery from before the earthquake to find out where people had lived, where buildings were, where roads were. And then afterwards, they could see where people were congregating, where things were knocked down, where they needed help. So when the Nepal earthquake hit, people started editing within 24 hours of the disaster. You can see here they set up a makeshift table, sat down on their computers, and got to work. You can see the statistics on the left, but it's used by rescue NGOs, aid groups, to know where to go. It should activate, I think. There we go. This shows all of the edits as they're being made through time. Thousands of people jumped in to help with this, and within a few weeks, the entire area was mapped, allowing connections to be made. It sped up the movement of food and supplies to the villages, and probably saved more than a few lives. I'm also very passionate about using maps for education. I think everywhere could do with a little geography, add some perspective, and actually it's pretty fun. Last year I worked with a group in Roche Noire, a secondary school there, a girls' secondary school, and we did 2-day workshop on mapping their neighborhoods. So you can see here the girls, I sent them out in the field with a blank map of their neighborhoods and asked them to fill them in. It's a program called Field Papers. If you're interested in mapping, check it out. It's very low tech. You print an atlas of where you'd like to map, take it with you, and you can fill it all in. The next slide. You can see in the right-hand corner, there's this QR code, and you scan it back in, and it goes right back to where it belongs on the map. So then you can trace it, and that data comes with it. So here are 2 maps I chose that were done by the girls. Some of them did it on the bus on the way to school. I know they did, or right before I asked for them. But there was quite a lot of detail. And yeah, you can see what they saw. I mean, I asked them to map 5 different things that were interesting to them about their neighborhoods. It's not limited to youth. We also use maps to teach professionals a thing or two. I did a session here in September with University of Mauritius, and I had 35 students, 34, 35. And it was open source maps. So it was not limited to QGIS, but we looked at a few other things, including the field papers that the students at Roche Noire used, and OpenStreetMap. I've mentioned this a few times. Has anyone ever heard of OpenStreetMap? Nobody. 1 person, 2 people. All right. Wonderful. So OpenStreetMap.org, what is it? This is a picture of OpenStreetMap from Mauritius taken a few weeks ago, I believe. OSM, it stands for OpenStreetMap. It's crowdsource map. By now, you're familiar with crowdsourcing? So if you've heard of Wikipedia, it's called the Wikipedia of maps. And the goal is to build the most detailed map of the entire world by the entire world. So it's predicated on open data, which is very important. You can add your data to the map, which you can do with other things like Bing and Google. But with OpenStreetMap, you can actually take the data from the map and use it for your own purposes. This is very important. It doesn't belong to everybody. It belongs to everybody. It doesn't belong to anybody in particular. So I think that's actually it. I think that's where I can wrap it up. If you want to start editing Mauritius or any other place in the world, you can go to openstreetmap.org. You can also help with, I said, the Nepal earthquake. There's tasks with Hot Awesome that you can go on and start mapping any part of the world that you're interested in. They're trying to get people to map places before disasters actually strike so that responses can be even faster. You can navigate with OpenStreetMap. If you're currently using someone else, you can find your way. If you put your 2 places in like we did earlier, you'll get directions just the same. And you get to pick a pretty good username. So this is the screen.
All right.
Oh, other resources, if you're interested in this, there's so much out there. If you want to continue to learn, I have a website, maggiemaps.com, and there's a resources tab. This is only 2 parts, but there's data sources, education resources, and a couple other things on there right now. I'm spacing on that. But, and if you have any questions about them and I don't get to talk to you tonight, please feel free to send me a message. I'm going to take questions.
Thank you so much, Maggie. We'll all just give you a round of applause for taking us through mapping and to bring it home and see how. I didn't know about OpenStreetMap, to tell you the truth. Even when I look at your slides earlier, I just didn't click. But I didn't know there was a Wikipedia for maps, and we can map Mauritius. So all of us can actually start mapping, right? All right, great, guys. So the way Science Cafe works is we have a presentation, and then the part is you guys can share things and ask questions, and we have a mic. On peut parler en français, nous cause créole, nous pose question, et on va traduire, et puis we'll ask Maggie questions. I know our experience running this, people are really shy to ask questions, but you shouldn't. I mean, I have some questions, and I'm going to actually start. I'm going to be very selfish about this. Maggie, when you have those balloons and those, the balloons and the, what are they called? The drones. What about the privacy issue and the legal aspect? Can I just take a balloon in my community and go around people's houses and map? I mean, is there a law for it or against it?
In some places, I guess laws are all jurisdictional, really. If you're walking on public land, it's never usually a problem. For drones, there are more and more no-fly zones. So within 5 miles of an airport, near government buildings, certain places that often don't even allow you to take pictures from the street anyway. Now in the US, I don't know the laws everywhere, I apologize, but in the US you're required to register your drone, even if you are not a commercial user, even if it's just for fun. So I think that they're starting to better understand what the risks might be and what the rules should be related to those risks. I know in Mauritius they had one event where they said no drones were allowed to be flown. I think it was a parade for the government. I saw that on the news, but other than that, I'm not sure what it is here.
Thank you. I didn't know about the registration of the drones. I'm going to give you this mic, and I'm going to take, Niti's going to take the other mic and walk around and have questions.
Do you have another question?
I'm sure you have questions. I'm just going to walk around, hands up for questions. There's a group of anthropologists there. I'm sure they have questions. You think maps going to be useful for you guys?
Drones are really used in archaeology quite a bit.
Anthropology.
Anthropology, sorry.
Have questions? No more questions?
Hi. So it sounds like mapping is two things. First, you collect data, and then there's a part of it where you analyze the data. What's your favorite part about it? Or is there another part that we didn't hear about or I didn't understand?
No, I think you've got it. Everyone heard the question? My favorite part is collecting the data. I love being in the field, bitten by mosquitoes, falling into swamps, getting caught in the briars. I'd rather collect all the data, honestly, and hand it to another analyst, but I realize, yes, there are two pieces to the puzzle.
Hi. I had two questions. Thank you very much for your presentation. I'm afraid I missed half of it because I came late. The first question is, I was really interested in the humanitarian map that you presented. Are you aware of similar maps being made in conflict zones? Because I understand that those were made in areas that were blighted by natural disasters, like Haiti and Nepal. My second question is, has any kind of mapping, like open source mapping, been done in oceans as opposed to land? Thank you.
Great questions. The first one, conflict zones. I believe there's an effort to map as many places as possible. I mean, I know that. I don't know anything specifically, but I do know some people who have been working with aid groups and large NGOs to use OpenStreetMap to start mapping those places, especially in conflict zones where you can't necessarily go, but you can start mapping from your couch. So yes, I believe if you, probably even through Hot Awesome would have some sites that need mapped that are undergoing conflict. As far as open source and sources for ocean maps, I think it's a wonderful idea, and actually I'm not sure that it exists. I know it exists for historical. There's Open Historical Map. There's Open Aerial map as well. So that's places where people are sharing free aerial imagery, other places where they're starting to map historic places throughout the world. But no, thank you for that, and I'm going to look into it when I get home, actually. So it would be great for someplace like Mauritius.
Hi, thank you again for the presentation. I actually want to answer your question about humanitarian regarding conflict areas. Can you hear me? About myself? Yeah. Well, I'm gonna. So my name is Adish, and I've worked in GIS, and I still work in GIS, and I work in humanitarian as well. Regarding open source for humanitarian and conflict zones, there's something very interesting that has been that started in Kenya, probably some 15 years ago now. So there were riots in Nairobi, and it is Ushahidi actually.
Ushahidi,
Oh, so
yes.
you know. Well, Ushahidi has developed at a level that has been, it's worldwide now. So mapping and data crowding, open source and crowdsourcing data for humanitarian purposes and mostly conflict areas. It's been working quite well. They've got really good products for that. Doesn't work always, but it's quite good. And so just to give a background, Ushahidi is that started as a small NGO, and well, it started as a project during riots in Kenya, in Nairobi, when they asked people to basically take their phone, take a picture, and tell the location of where something is happening. Are they killing people? Are there riots? Is something happening there? And then that would be sent to a center where they would process and map that around, so they could see like density of where the problems were in Nairobi. From there, it's quite a big company now, and they've got quite really good products from, you can get internet anywhere in the world with their products, for example. Yeah, that would be it.
Thanks, Adish. I almost showed a video from Ushahidi because I think they're doing good work as well. Any other questions?
Okay, it looks like we have a car, 4298 ZX. 4298 ZX08. 4298 ZX08, la voiture. Merci. We're going to have questions. You guys, CafSci is ongoing, and we're going to close it soon, but we're going to be around. One question I had, I've been 13 years away, basically living from Mauritius, and I left, and there were a lot of green spaces and fewer major streets. And I came back, and I could see visually the number of streets increasing, and I'm kind of feeling that in another 10, 13 years, there will be a lot of built-up areas. From a mapping perspective and from an environmental perspective, is there a ratio of land, natural land, to built-up area that we should not exceed? Is there something we could do for Mauritius because it's a small island and we cannot keep building? Should we respect a ratio of built-up area? And not only that, even the existing land, we are just putting concrete everywhere, and we're not even leaving enough spaces for water to be absorbed or whatsoever. So how does your projects and mapping you're doing help us understand this, and what Mauritians could do so that we could better chart our built-up area forward, going further, you know?
It's a very loaded question, but I'll do my best. My experience as a city planner is you have to be very careful with these things. But what you could start to do is better understand your existing land use. And what I think the most about in places that are developing rapidly is whether or not they are checking to see if it's safe. Have these areas been looked at? Are they wetlands? Is it a flood-prone area? Are they on a slope? What does it mean for a river that's flowing through? If this is carrying refuse or if it was polluted, is this going to go into a water system if that landscape is changed? So for me, I always start where you are. Better understand where the development's occurring and how that affects the existing ecosystem. I mean, you could go back in time and you could say, well, this used to be all pine trees, or this was a wetland, and that would help you get a better idea of how quickly things have changed, but there's not much you can do now. So my suggestion would be is to start figuring out what's going in, where it's going in. I know that the Ministry of Lands has information about this, but it's been very difficult to find a lot of different layers for Mauritius, so I don't have that information, but that helps. OpenStreetMap, you can put anything on it, down to a signpost.
Any more questions? Oh.
Hi. What's the biggest challenge you've had gathering data in Mauritius from the government or for your own collection techniques?
I haven't really had a project yet where I was forced to really try to get data here. I know that some data is actually for sale through the Ministry of Land, but to me, the most important thing about data is its reliability. So I'm prone to collect my own data anyway. So depending on what that is, I guess the challenge is time, and materials and people. Like if you want to map all of the rivers in Mauritius, how are you going to do it? I prefer boots on the ground paired with satellite imagery. So if we were going to go out tomorrow and map all of the coral reefs, the challenge would be humans and boats and the technology to do it. But my opinion is, especially with OpenStreetMap, if you want the data, you can build it yourself. It's a duocracy, as they say. So, thanks.
Any more questions? Oh. There's one. We're probably going to take one last question, if you don't mind. Two last.
Thanks. Yeah, thanks for the presentation. First question is very simple because I didn't get the answer, which is the quickest way to Port Louis. And second one, it's like a political geography question, whether it will be possible maybe to look at the road constructions in Mauritius and how they correlate with which parties won the votes, to see, in which regions, how it gets developed, whether there is some pattern. Thanks.
It's totally possible to do so. And I think the quickest way to go to Port Louis from here is to use the drone. I don't know. Fly or go on a Sunday. As far as political mapping, yeah, I mean, there's some companies out there that focus solely on this. I don't know what the term would be in Mauritius, but in the U.S. there's something they call gerrymandering, and that's changing the boundaries of districts to get a certain number of votes. So, a senator can come in and draw a new line and say, this is now Pleasantville. And they call that gerrymandering. But I'm not sure. I mean, you can create that layer in GIS. I mean, you put all your data together and you can start to see patterns for sure. So if you have that information, yeah, sky's the limit. Thanks.
Last question. How easy is it to get funding? Yeah, sorry. Go ahead. How easy is it to get funding for making maps?
Funding for making maps?
Yeah.
Well, it's not that. I don't find it to be that easy. But it depends on what you're going after. I've only presented to angel investors once in my life, and I was trying to get funding for a program I wanted to start called Map Girls. And I wanted to bring mapping into schools around the world. And that didn't go so well. Depends on what you're mapping. my next challenge is going to be to find funding for some of the conservation work we're doing in Southern Africa, so I can get back to you, hoping to have more luck.
Thanks.
All right. Thank you. I think we're going to formally close the session now. We are here. Maggie is going to be here. So a few credits and a couple of announcements. Thank you very much for all of you to come over on a Wednesday evening. Nice weather, luckily. And to be part with us with CafSci, Café Scientifique Maurice. The whole idea is to bring the science debate out everywhere. And please help us if you know any good speakers visiting, if you know any other venues in Mauritius we want to check out. As you see, it's a very informal setup. You come to a place, you consume. By the way, I think we are now, cocktails are on and there is more menu still on. Thank you for Big Willies for hosting us. I think Gerald and Fred are somewhere here, and the whole team. And thank you, Silvano. I know has been running around with Michelle and Yuvi taking pictures and trying to bear with us. We try to put these videos online as best as we can. So do check out our Facebook website. We have a blog and we have a mailing list, and do spread the word because we have a lot of other topics. You can suggest friends. You might know people who might share a talk about something else. It could be in French, it could be in Creole. And that's it, guys. Thank you very much for coming. Maggie is here. We are here. We can talk more about Café Scientifique and mapping. Okay, she has her final slide. Thank you for coming, and à la prochaine. Bye. Thanks.